All right. So I'm going to draw a circle. Oh my gosh. So I'm redoing the circle. Okay. So let's label this in terms of, so we're going to use our special triangles. Do we remember what our special triangles are?
Yes.
What are they? 45. So we have 45, 45, 90, and 30, 60, 90. Okay, so we're going to use our special triangles. We're going to derive, aka make the unit circle from scratch by using our special triangles.
So do you want us to draw a circle?
Yeah, maybe have a separate piece of paper. I don't know where you would put this. Maybe on the very back. Is there stuff on the back page of your notes? No. Okay, this is a good place to put it then. So this is 45, 45, 90. Okay, so let's start by labeling the 90 degrees because those are like the easiest ones. You know what I mean? Because both of these triangles have 90 degrees in them. So let's break this circle down into 90 degrees. So I start with 0 degrees. What's next? Let's count by 90s. 0, 90, because this is a right angle. So that's a 90 degree angle. 180 is halfway around. 270, and then I'm back to 360. Okay, so the angles I have to use are 90 degrees, 60 degrees, 30 degrees, let's see, 90 degrees, 45, and 45. Let's do 60 degrees next. Let me check this off. So I've finished the 90 degrees. Because what I'm looking for is all the multiples of 60 degrees in my circle, because I'm trying to use my special triangles. Really, those are the only two triangles I'm going to have you use for your test. Okay, so let's count by 60 degrees. So it goes 0. Which one's this?
30.
So I'm counting by 60 degrees.
60.
60 degrees. Count by 60. 0, 60. Oh, Liana said 120. 180. Oh, 180 is already there. Interesting. 180 is already there. Okay. 60, 120, 180. What's the next one? 240. It's close. And then add 60 again. 300. Add 60 again. Oh, I already have 360 there. Wow. Okay. So that's okay. So I counted by 60s. Now I'm going to go through and count by 30. So I have the 60s done. Let's count by 30s. 0, 30. Okay. Let me draw this bad boy up in here. So 30 degrees. 0, 30. Oh, 60 is already up there. 90 is already there. 120 is already there. 150 is not on there yet. Maybe you sense a pattern that relates to what we did in class the other day. Interesting. That's why I'm color coding it, so you can compare it to the rest of your notes. Okay, 0, 30, 60 is already there, 90 is already there, 120 is already there, 150, 180 is already there, 210, okay. Oh my God, come on. Oops. 210. Okay, plus 30. 240 is already there. Plus 30. 270 is already there. Plus 30. 300 is already there. Okay.
330.
Oh, 330. Okay, 330. And add 30 again. 360 is already there. Interesting. So if you see all the 30-degree angles, interesting. Think how that relates to the other stuff we did. Notes. All right, 30 degrees is donezo. Let's go on to 45. So we'll start at 0. Halfway between 0 and 90 is where 45 is. So 0, 45. Plus 45 degrees? 90 is already there. What the heck? 0, 45, 90. So if you have a calculator, you can just add that puppy in. 135. So 135 is between 120 and 150. Plus 45 degrees? 180 is already there. Dang. Okay. Plus 45? 225 plus 45 degrees. 270 is already marked, so okay, we keep going. 315. Okay, so that is all the angles of my special triangles. If I wanted to, I could draw in like, 82 degrees, and it would be between 60 and 90, but why? Really, the only triangles we're going to use are 45, 45, 90, and 30, 60, 90. So you are only responsible for these. And the cool thing is, we can actually make a shortcut, right? We can make a shortcut. So when finding, if I wanted to find I don't think I did reference angles with you guys, shoot. That's the next thing we're gonna do. What I want you to notice is the fact that all of the 30 degrees ones, these four are all related because they all are equivalent angles, meaning equal. The angle between the x-axis and the terminal ray. So what I mean by that is the angle between the 30 and the x-axis, that's 30 degrees. The angle between the x-axis and the terminal ray, that is 30 degrees. So I just wanted to make that clear. So this is another way to derive what we did last time in class. Do we see? So when I was talking about only circling the fractions that didn't simplify, this is what I meant. Remember all those times I was like, oh, it's already there, we skip it. Those were the ones that reduced. Okay, so let's go back to the notes and I'll show you what the hell I'm talking about. Nope, that's not what I want. Okay, so for example here, this was 180 degrees and this was 360. So when I was labeling my 45 degrees, I went, or sorry, what is this, 60 degrees? When I was labeling my 60, I went 60, 120, oh, 180 was already written, so I skipped it. And then I went to my other ones. Similarly, when I was going through 30 degrees, this was 30 degrees, this is 60. I had already drawn 60, that's why I skipped it. 3 pi over 6, well that's 90 degrees, and I already drawn it, so I skipped it. This was 120 degrees, I already drew it, so I skipped it. And then I get to 150. This is like the two different ways the math department here teaches this lesson. So first, we can go through with all the fractions. Literally, it's like, oh, count to 100 going by twos. 2, 4, 6, 8, 10, whatever, right? You guys know how to count by twos. If I told you count to 2 using a third, using thirds, okay? 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. More or less, that's what I had you guys do, was break the circle up into pieces. Okay, hopefully this will help a little, because the next thing we're going to talk about is reference angle. The reference angle is the acute angle formed by the terminal side of and the nearest x-axis, formed by the terminal ray and the x-axis. Wait, that's literally what I was talking about when we were doing this guy. It's formed by the terminal ray and the x-axis. Here, if I wanted to find the reference angle for 210, so reference angles are literally, I have this angle that is like more than 90 degrees. Is there an angle between 0 and 90 that is quote-unquote equivalent? So reference angles are equivalent angles. You're looking for, can I, instead of having to do like sine of 210, can I do sine of something I know? So I look at 210 degrees. So I'm going to highlight this one. So this is the angle for 210 degrees. Do you see how I drew it in blue? I had my initial ray, my terminal ray. No, don't die, don't die. And then it goes all the way around. I do not want to do sine of 210. That sucks. I don't know. What triangle is this? Baloney. It's not a triangle. So instead, what I want to do is find a reference angle, a angle that is equivalent, that's between 0 and 90, because then I could use my special triangles to figure it out. So what I want to do is find the x-axis, my terminal ray, and figure out what angle's right here between the two. What angle is equivalent? 30. So I'm going to give you a little like cheat sheet of how you find the reference angle depending on the quadrant. So we have 4 quadrants. Literally, if you're in quadrant 1, surprise, you already have your reference angle. Reference angle is, I'm going to say real angle. That's not a math term. I don't know. That's just me being stupid. Whatever, literally the angle you're trying to find, that is your reference angle. Like, you're not changing. If I was looking at 30 degrees, what's the reference angle for 30 degrees? 30 degrees. Okay, that should be the easiest question for you.
Oh, because it's like 35, 45, 60.
Because reference angles always have to be between 0 and 90 degrees. If you're in terminal 2, how would you find your reference angle?
Your 60 is 120. Your 45 is 155.
So you take 180 minus whatever your degree is. So you're right. So looking at this, you could easily see what it was. Oh, let me plug in my computer before I forget. Okay, let's talk about this first. So if I'm at 120, if I go to 120, I'm looking for the angle that when I add it will equal 180, because 120 plus whatever angle will be supplementary. They will equal 180. So what you do is you take 180 minus whatever your angle is, and that will be your reference angle. In quadrant 3, just like what we did, if I did the angle minus 180,
You add again.
so I'm doing angle minus 180, that will be your reference angle. So here I had 210 minus 180 is 30 degrees. And if I have an angle in quadrant 4, I say 360 minus my angle. So notice I'm always dealing with the x-axis between your terminal ray and your x-axis. Okay, it's like a little cheat sheet. Little cheat sheet. All right. Let's go to notes. Okay, sketch each angle and give the reference angle in degrees. Yes?
No.
You want to do it?
Yeah.
All right, do you want to do it up here? Okay, I'm going to grab my charger and let's see if you can do this one. So you're going to have to draw the angle. So we've done this before. We've drawn angles, and then you have to figure out the reference angle.
Yes, sir. I'm just trying to get the participation points. Oh shit. Fuck.
No pressure, no pressure.
All right, how are you gonna draw 360?
So I know that this is 360, this is 90, this is 180, and this is 270. So you start from here, you go around, and you end up, I guess, in the middle of 270 and 360. Oh, okay.
Sorry. Oops, sorry. Okay, here. You can do this in a different color. Here you go. Do this in a different color. There you go. Okay, it's fine. Here we go. Sorry, redraw. I just want a different color.
Okay.
Perfect. So he knows it's a positive angle, so we're going counterclockwise. Awesome job, Jonah.
Good job, Ted.
Okay, so
Prior to initial and terminal rays.
so don't you do 180 minus 330?
Let's see, which quadrant are we in?
Four.
So if I went all the way around, it would be 360, but I only went partially the way around.
Yeah.
So in quadrant 4, you take 360 minus your angle.
This is way too big, I'm sorry. So it'd just be 30.
Yeah, that's it.
Would I put the degrees or no?
Yes, because this is all
Okay.
degrees.
Just making sure.
Sweet. Yeah,
Is that it?
you're supposed to. Oh, well, here. So I'll show you. Okay, so good job, Jonah. So we have my initial ray, my terminal ray. I'm just going to redraw this guy so it's a little more clear. So I know that, ready for the trick? I know if I went all the way around, I would be at 360, but I didn't. I only went 330 degrees around. So 360 minus 330 is 30 degrees, meaning this angle right here is 30 degrees. Cool. Let's do the next one. All right, if you want to come up. Sure. I do this way. Perfect. Did I ask to sketch the reference angle?
Yeah.
So what I wanted was like
Just the
here,
squiggly?
like here.
Oh, got it.
Alright, so this
Okay,
was Jonah and Ari.
So
Momento, por favor.
152 is in the second quadrant. So you're going to do 180 minus 152.5, right?
Yeah, well, yeah, I would draw it first.
Just 27
Perfect. Okay.
degrees.
Just make sure you draw 152.
152 is somewhere like here.
So you want to make sure you go from your initial ray.
So I go
over to
from
your
my
terminal.
initial ray, and I'm going counterclockwise,
You're going counter. Yeah, perfect.
which is
so it's
like right
positive.
there.
Sweet. And then your reference is
And
what's between
my-
the x-axis and your terminal.
Which is 27.5. So that's like right.
Sorry. Yeah. So what I really want to show people is like the fact that like this is 27.5
degrees. Got it.
because this is 152.5. Oops. 152.5 degrees, and together they equal 180.
Yeah. So you can finish.
Yeah. Well, is that it? Label degrees for me because I'm not doing it. So I decided I'm only going to be giving you like positive angles. I don't want to confuse you guys too much because this is a lot of new information. I believe I put a negative.
You put 2, yeah.
2 negatives. So let's do it. Let's do it as if it's positive. We're doing it as if they're positive. Okay. Sorry, but you know, I'm just trying to
Thank you, Miss O'Brien.
make it easier.
Appreciate it.
I just did it.
Let's, because that introduces a whole other thing. Okay, so Starla and Zach you guys said you want to do it. Okay, so this is positive 240 and positive 800. Okay.
Okay, so we do this. Okay, should I label the sides?
Yeah.
Okay.
Well, if you want, that'd be great. So make sure when you're drawing these, you draw your initial ray, you draw your terminal ray, you draw the arrow going from initial to terminal. Awesome. No? What? Sorry, what did you say? You have to go this way. So positive goes around counterclockwise, negative would go clockwise. Yep, this is why I'm not. Next year, if you're in turbulence algebra, you're gonna cover it.
Wait, first, since it's quadrant 3, I do. What is it again?
Let's see.
I forgot my
You're
paper.
always wanting to go between the x-axis and the terminal. So here I'm like, wait, if I went halfway around, I'd be at 180, but I went 240 around.
Mm-hmm.
So what I do in the third quadrant is the angle minus 180.
Okay, yeah.
Angle minus 180.
This angle should be more down. Doesn't matter.
It's fine. It's in the third quadrant as long as you understand.
180, 60.
So now I'd pick a different color and like show the angle between the x-axis and the terminal. What?
You add 180 in the third quadrant.
I think I said angle minus 180 in the third quadrant. Huh? Yeah, angle minus 180. And
Wait, how do I erase?
Okay.
How do I erase?
which what are you trying to
I
erase?
just want to erase that so I can do a different color. Because I already went over
And
it.
say
But no, but I did this before.
it's okay. Here, just pick a different color.
Yeah.
Select a different one. Okay.
What?
That one. Okay, because that's a highlighter.
Okay.
Just a second. What is this nonsense? This is not being on task. There's just too much noise. I can't deal with that.
I think it's close
No.
because that can't be 60 degrees. That's it's 240. It's 420 degrees. You add because from 180 to 270, you're adding. You're not subtracting.
No, you're subtracting because you have to get a number in the
What is
first
this?
quadrant.
What is this purple?
The angle.
It's not. Which angle are you talking about?
The one that I did.
The reference? No, the reference angle is between your terminal.
Oh, you're doing
and
the
your X.
reference. Okay.
Yes.
Oops.
Okay, so let me show you why. Let me show you how I derived these, okay? So this one, let me show you here. Okay. So I had an angle that is 240. So it looks like that. This is 240 degrees. Imagine if I went to 180. And then this is going to be the reference angle. So I'm just going to do Theta R, theta is angle, R is which angle? Oh, R is my reference. Theta R is my reference angle. I'm just showing you which angle it is. So together 180 plus whatever my reference angle is. Don't be scared of theta. Theta is just a variable. I'm just trying to figure out what angle I'm trying to like find. Together they should add to 240. How would I get the angle by itself? How would I get the angle by itself? Subtract 180. So literally it's whatever angle you had minus 180. So I'll go back to this document. Yeah. So in quadrant 3, it's your angle minus 180. And that will give you how many degrees are between the x-axis and your terminal side. So the next step, the next logical thing would be to talk about if the sine, tangent, or cosine, if the ratio be positive or negative. Unfortunately, Algebra 2 does get there. We're going to run out of time. We're not going to be able to tell you. But if you're taking trig and advanced algebra, you will learn all students take calculus.
Not me. I'm not.
So that's the saying. Do you see the letters I wrote? That's the saying. You're going to miss this. Give me like 2 seconds. This is the saying. So this tells you what is positive in the quadrant. All are positive. Sine is positive. Tangent is positive. And cosine is positive. It tells you what's positive. So here in this quadrant, if I was trying to take sine of 210, at the end, I would have a number that is negative. Even though I'm using a reference angle, which would give me a positive number at the end, you're right. So this is like, what the hell? I understand. Don't worry about it, because you'll learn it next year if you're in trig and advanced algebra or pre-calculus. All students take calculus is just the saying. It's kind of like, how do you remember PEMDAS? Oh, please excuse my dear Aunt Sally. It's like nonsensical sentence. Okay, let's keep going. Perfect. Questions? Thanks, Starlight. Yep.
This kind of relates to the next one, but what will you do if it's past a quadrant?
Aha! All right, Zach, you're up. Let's see if we can figure it out. I'm just labeling this. What? It depends where you are. Do you want me to do this one?
I go in circles, right?
You keep going around, and then you'll end up someplace. I recommend picking a different color. How about that one? Is it selected? No. Click on it again. Yep, it's good now. Okay, so draw your initial ray, draw your final ray.
Yeah, you can do this one.
Waiting for the problem to start.
You shouldn't be screwing around. You should try it yourself. How do you think this is going to happen?
I got it.
800 is going to be, well, that's more than one time around. So if I subtract 360, what do I get?
You got like 540?
No,
you get 440.
440. Wait, that's still more than one time around. So let's track 360 again. 80 degrees?
Yeah.
Okay, so what this means is I subtracted 360 twice. So I'm going to go around the circle twice, and then I'm going to go to 80 degrees. Okay, so here's my initial. I'm going to go around one time and two times, then I go to where 80 degrees is located. Let me do that again. Okay, so I go around one time to 360, two times to 720, and then I go 80 more to reach 800. One, blah, 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 up here. Okay, cool. So this is my 800 degree. Pause, think. Where's my reference angle? I gotta go between my terminal and my x-axis. So let me just draw that. Between terminal, x-axis. Terminal, x-axis. What's that angle right there? 80 degrees. Hey. You did. I'm really happy I didn't stab you in your eye. Hey. Okay. Questions? I understand. More practice. More practice. No, you don't. But I am going to make you do another problem. What?
Can I do this?
No, she's just about to make
I have a question actually. Hop on that.
So, now, guess what we're going to do? Instead of doing in degrees, we'll do it in radians. Hey, radians.
Should we just calculator radians?
It depends what your problem is. If your problem, I'm wanting like sine of 50 degrees, then you have to be in degrees.
Will you tell us like on the test when I change it back and forth?
No.
Like his negatives? Oh.
If I'm asking for how many degrees, blah, 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 and then like, and a lot of times, the only time you're really going to need a calculator for this test is like at the inverses. If I'm trying to find the angles. That's really, yeah. Because all this like reference angle, I mean, you're going to have to draw it. Your calculator will not draw it for you. All right, sketch each angle and give the reference angle in both degrees and radians. Oh gosh, so first step of what I'm going to do. Are we ready?
Oh my god.
Okay, let me see if I made any notes for myself that I wanted to talk to you guys about. No, I'm okay. All right. Okay, here we go. Ready? So I want everyone to put your hands out in front of you and have it up. Okay.
What are we waiting on?
No, what? Come on. I'm waiting for everyone. I don't care. You may look funny. So close your eyes and take a big breath in. And like exhale. Okay, this is what we do in yoga. And like literally it seems really funny, and like weird, but actually it's super good. Let all the negativity and like self-doubt leave. Leaves your body. And ready? Math boss energy entering.
Do you teach yoga?
No, but I do yoga. Okay.
How often do you do yoga?
Like 2 or 3 times a week.
Do yoga at school?
No.
You should.
Go to my gym. Anyway. Okay. All right. Ready? Math boss energy. Let it into your brain. Okay. Ready? Now we're gonna be math bosses. Okay. Math boss. Half of taking an SAT or a test is literally mindset. You just gotta walk in and be like, I know my stuff. Don't be like overconfident, but like, enough confident. Okay, so we can do this. Ready? Let's figure out what is this as a mixed fraction. So how many times can 6 go into 14? Twice. How much is remainder? 2. 2 6 times pi. Oh wait, can I say 2 and a third pi? Pause. How did we get from 14 over 6 to 2 and a third? Made it a mixed number. Okay. You feel it in your brain? You can do mixed numbers. You can do it. Okay. Math boss. Hell yeah. Hell yeah, you are. All right. Just break this down as much as possible. So now let's count in radians. So I start at 0 radians. All the negativity left your body. Halfway. How many radians are in a complete circle? If I go one time around, 360 degrees, 2 pi radians. 2 pi radians. If I go halfway around, how many radians is it? Pi. If I go halfway between 0 and pi, it's literally halfway, so it's half of pi, aka pi over 2. Okay, pi over 2. And halfway between 1 and 2, 1.5, also known as 3 pi over 2.
This is not
At minimum, I'm expecting you guys to be comfortable and be able to label this. So if you're not ready yet, got practice, right? Let's go through the homework.
These next two negatives and the positives before ready?
Yeah, we're gonna do that. Okay, so we have our axes labeled. You really got to keep it together. It's like the 5th time caught you turning around causing hubbub. Gotta stop. Blame him all you want.
I'm not blaming you.
You're the front row. You can literally face forward. Okay, we're gonna go to 2 and 1/3 pi. Are we ready? We're gonna go to 2 and 1/3 pi. So
go around twice.
1/2, 1, 1.5, 2, and then I'm going a third more. So this is 2, and this is a third of the way to pi. So this is 2 and 1/3 pi. Because if it was 2 pi, I would go around 1 time. But then I went 1/3 pi further. So 1/3 the way to pi. So I need to find my reference angle. Throw back to 5 minutes ago when we remembered it's between the terminal ray and the x-axis. What is this angle right here? What is this angle?
That's 60.
Yes, pi over 3, which is the same thing as 60 degrees. But here, well, hint, hint, literally I'm only giving you 45, 30, 60, 90. Those are the only angles you will have for reference because those are their special triangles. Aha, okay. How did I know it's pi over 3? How? How did I know it's pi over 3? I am Darth Vader. How do I know it's pi over 3? Yep.
Oh, this is like 180. Because it goes 1/3 of the way.
Because it goes 1/3 of the way. Literally, I went around one time. That got rid of my 2 pi. Nope, do we hear what I said? Probably not. We're not facing the teacher. All eyes are not on me. Okay, so 2 and 1/3 pi. I went around all the way around one time for 2 pi. And then how much further did I have to go? 1/3 of the way. 1/3 of the way to pi. So literally my reference angle is 1/3 pi. And then we know pi over 3 is 60 degrees.
How do we know
If you didn't remember, we can convert. To go from radians to degrees, you do 180 over pi. This is the conversion factor. What is 18 divided by 3? 6. So 180 divided by 3 is 60. All right, cool. Let's try the next one. Hey, okay. Let's make this positive 5 pi over 4. Coolio. Positive 5 pi over 4.
So there are going to be no negatives on the test.
Not for reference angles. Let's see. I already marked Zach for a point. Do you want to try this one? Zach. What? Yeah? Okay.
Oh, we know.
So with radians, the trick is I write it as a mixed number. What?
That's one of our special ones.
Surprise. Every single one is a special one.
No. I forgot how to simplify that. 65, 35, and 45.
Oh, is it positive?
Close. So I'm making it positive, sorry. So what is 5 over 4 as a mixed number?
Isn't it?
1 and 1/4.
Yeah.
So 1 and 1/4 and then 5. Okay, so he converted 5/4 into 1 and 1/4 times pi. Meaning he's going to go to pi and then 1/4 further. I'm going to label 0, pi over 2, pi, 3, pi over 2. So he's labeling his axes. Recommend you do the same. Okay, so 1 and 1/4 pi is definitely going to be between pi and 1.5 pi. How do you figure out where to go, Zach?
You just know.
Great. Okay, so what you're trying to do is 1 and 1/4 pi. So you're going to go over to pi.
Yeah.
And then how much further?
1/4.
1/4 of the way back to here. So you're going 1/4 of the way back to here. So it's 1 and 1/4. Another way to think about it is here's 1. Here's 1 and 1/2. 3 over 2 is 1.5. So I'm looking for, it's between 1 and 1.5. Draw your terminal ray. Draw your. Okay, ready? Follow my finger.
Terminal.
Initial. Okay.
No.
Okay. So I have my angle. Pick a different color. You have a new color? Now is when I'm trying to find my reference. It's between the x-axis and the terminal. So you're going to draw this angle. Draw the line here, angle.
Wait, like
Yeah,
that?
perfect. And then
Okay.
angle. Perfect. So he found, okay, the reference angle is always between the terminal ray and the x-axis. Interesting. How can you find this reference angle?
You see it?
Do you want this point?
Yeah.
Okay, so in degrees, how did we do it? I knew if I would go around to here, it would be pi, but I went all the way to here.
So it's
literally
pi and
gonna be
1/4.
Pi plus some angle is going to equal 1 and 1/4 pi.
220.
Okay, so I know pi And pick a different color. So I know pi plus whatever this angle is going to equal 1 and 1/4 pi. Pi plus whatever that angle is going to equal 1 and 1/4 pi.
Oh, so you subtract pi.
Yes. Subtract pi. What is my angle?
Just 1/4.
Literally,
Pi.
1/4 pi, 1/4 times pi, pi over 4, those mean the same thing. 1/4 times pi is literally pi over 4. Hey. Okay, what angle is this? Convert. Multiply by 180 over pi.
So this is Ryan, can
It's like 30.
You guys need to do like
Can I borrow someone's calculator? Jeremy,
I mean,
can I borrow?
don't put banana cells in the back. Not sitting.
100%.
Shit, where's my...
100% not sitting.
Thank you. Oh, 45? Yeah, I was wrong.
And then, so I want
No, she's so tempted.
45, sweet. Let's do the next one. How'd you get it?
She just got it now.
God dang it, Zach!
No.
How do you convert
you
from
do
radians to degrees?
you do 180 over pi.
180 over pi. Why are you multiplying by 180 over pi and not pi over 180?
Because
You want to cross out the
you wanna cross
pi,
out
and
pi.
you want degrees on top. I don't think we're listening. I don't think we're listening at all. So we want to cross out the pi, and I want degrees on top. This should be 180 degrees. I don't know if this is 0 or degree.
Oh, my bad.
Degree. Okay, cool. Thank you. So the pi's cancel out. 180 divided by 4 is 45. You'll have your calculator, so if you're ever in doubt, you can just like check it out. Right? Sure. Hey. I'm sorry I almost poked you in your eyeball when I threw a pencil at you. Okay, so I'm going to do part C. That way we get an idea of what it should look like. Hey. Okay, make it positive. First step. First step. Oh, sorry. First step. What? This is crazy. I don't know. 42 on the bottom. Can I reduce this? Simplify.
By 7.
5 pi over 6. We can do this now. We can do this. Okay, so 5 pi over 6. Interesting. Let's see. How do I do this? 0 pi. Halfway is pi over 2. And this is also 2 pi. This is 3 pi over 2, aka known as 1 and 1/2 pi. Okay. Just to like, I don't know if this makes it easier writing it this way, but like visually, I'm trying to break this up. So 5 pi over 6. So I know that this over here would be 6 pi over 6, because that's the same thing as 1 pi. Yeah? Maybe? Okay. So what I'm going to do is I'm going to draw some dotted lines here to help me figure out where to stop. So this is like, I'm breaking it into 6. So now there's 6 equal slices. 1, 2, 3, 4, 5, 6 equal slices. You don't necessarily have to draw that, but I just want to show you what it would be like. So we're okay with how I broke this up. Took a little pizza slicer. Okay. So because this looks messy, but because it's going to help me visually see where to stop, I'm gonna redraw this just a little bit. So I know that I'm going to have to go like here. That's about where 5, 6. 5, 6. 6, 5, 6. That's about where it is. Okay, so if this is 5 pi over 6, aka 5/6 times pi, what I really need to find is the reference angle, because I need it to be between 0 and 90 degrees, between 0 and pi over 2. So I'm looking for the angle that's between the x-axis and my terminal ray. Weird. So if we don't remember what to do, here's the trick. So I know that 5 pi over 6 plus whatever this angle is, has to equal going all the way across to pi. So let me write that. So I know that 5 pi over 6 plus whatever that angle is has to get me all the way over to pi, because that is a... So you do pi minus the angle, aka 180 minus the angle. Remember that cheat sheet? 180 minus the angle here in radians is pi minus the angle. Okay. So if I have pi minus 5 pi over 6, oh god, fractions and subtracting. But it's okay, because remember, math boss energy. How do I do this?
Pi over 1.
Pi, okay, I put it over 1. Now what, Matt?
Get this point.
Now it's
Get this
gonna
point.
be, that's gonna be 6 pi.
Let's go.
You have to, you find the common denominator.
Okay, so multiply by 6 over 6. Multiply by 6 over 6, so 6 pi over 6 minus 5 pi over 6.
Wow.
Okay, now can we convert into degrees? Convert to degrees.
Okay, well now you just do pi over 6 times 180 over pi.
Okay, and what would this be?
That's, calculate on.
18 divided by 6 is? 180 divided by 6, 30. Math boss energy. Math boss energy. Okay. See, this looked like a terrifying problem. Big numbers, 35 pi over 42, but you knew how to simplify it. Oh my god, 5 pi over 6, I don't know what to do. So I took a pizza cutter, sliced from 0 to pi into 6. Then I said, okay, here's where 5, 6 will be. Cool. And then every time when you're finding a reference angle, it's between the x-axis and terminal. Between x-axis and terminal. So then I use logic. I'm like, okay, if I go all the way around, it's pi, but I only went 5/6 of the way there. So I know my angle plus whatever the reference is has to equal going all the way to pi. So I subtracted my little fraction, and then, oh my god, we had to deal with the fraction, but it's fine, because we knew how to find the least common denominator. Check it. All right, so we want to do the next one. We're getting close.
Thank you.
That was good. Solid. All right, so I'll give him a point. That's solid. I love the math vocab you're using. You understood it.
Well,
Solid.
now that I already have a point, should I do this one?
Sure. YOLO. Let's do it.
He's not done.
Hey.
Never, ever saw.
Matt, are you writing?
I'm gonna write too.
Do you want to write? All right. What's the first thing you're gonna do?
Wait, is this being screencasted?
Yes, it is.
I'm not writing.
So Brian, I accidentally cursed on the screencast. Accidentally.
Oh my god. I'm gonna take the curse word. It's my new ringtone.
It's 4 1/3 pi.
I'm just joking. It's not. Okay. How many times can 3 go into 13? You said 4, and then I have 1/3 left.
Then you're gonna draw a graph. You can go around twice.
How do you know twice?
Because that's only times 4. Because, you know, if it's 2, then 2 goes
So
into
ready?
4 twice.
1 pi, 2 pi, 3 pi, 4 pi, and then 1/3 of the way. What is this nonsense? Go away. Okay. Okay, cool. So now what?
Now you have...
You okay?
I'm blowing my
Okay.
You're freaking me out.
So I'm gonna go to like another bathroom.
Now what? Now what?
And I have 1/3 pi.
How do you know?
Because that's what's left.
Because literally,
You're such a nuisance.
Is that on screencast?
yep.
Wait, subscribe to Miss Sophie on YouTube.
On YouTube,
Yeah, maybe we can get you monetized. and you
I
can
have
get
like,
ads
I think I have like 3 subscribers right now.
It's
What are they?
awesome.
I don't know, I've seen, yeah, he was the first one. I was like, why?
Okay. I
Okay.
have to convert that to degrees.
Okay, so you said convert to degrees?
Times 180 pi. And it's just the same thing. It's going to be 30, 60,
60, because 18 divided by 3 is 6.
That's 6.
180 divided by 3 is 60. Cool. Solid, solid. Clap it up. All right. It's 2 points for Matt Roney. All right.
Oh my god.
Hey.
Cry.
Do we have questions on how we did this one so far? Literally, since we ended in the first quadrant, the angle, our reference angle is literally just however much we're above the x-axis. That's it. Nice, easy. How much do I want to do? Okay, so we're actually not going to do the last 2 pages. We're not doing 12.6 at all.
Oh, thank you.
But, so that means we have 1 page left. Hey, and then we're done with new content.
I really wanted to.
Okay. It's fine. This is the last page of notes, and we have 14 minutes to go through it, which means you would have some time to go through and do homework.
You're gonna practice this.
You will have a practice test next week.
The
30th, which is Thursday. Because we were going to review on the 28th and the 29th, and the 30th is your test. So 2 days review.
Are you gonna play for the extra credit like you used to?
No, maybe. Maybe. I don't know. I don't know. Maybe I'll think about it if I have time. Whatever. Okay. Example 8. For each angle, find the corresponding reference angle, aka the equivalent angle. All right. Degrees or radians, and state the quadrant in which the angle is located. Okay, so if I give you something in radians, I want the answer in radians. If I give you something in degrees, I want the answer in degrees. Okay. And make sure we say which quadrant the angle is located. I will. There's going to be what?
Snapping.
Snapping?
There's been a lot of snapping going on. Oh.
It picks it up too. If you've ever watched a screencast, you would hear it.
I watch them every day after school.
I know for sure that's a no. Because sometimes the screencasts have 0 views, and I'm like, why? Okay, let's do the first one. No, it's like when I upload the one, I was like, it tells me automatically. It's like, oh, your video is performance. I was like, I don't care. Let me get the link so I can post it on PowerSchool. And it's like, you didn't have any views for the last 2 videos. Do you really want to upload this? Yes, I do. All right. Yeah, so we're gonna make these positive because I'm not giving you no negatives. Whoop. All right, so here we go. Interesting. This is exactly what we've been doing. We got 4 points up for grabs. Who wants to help for decision? Okay, let's have Ari, Jonah, and Zach. Sweet. All right. Ari, Jonah.
So it's in degrees, so I can keep in degrees, correct?
Yeah. Okay, so you're drawing it, you're showing a reference angle, and then you're telling me
Okay.
which quadrant it's in.
That's not what I wanted.
Yeah, let's make a different color.
He's done.
No, why is this all highlighter?
Hey, okay. Sweet, okay.
All right, okay, now where's the pen?
Top. Pick
Top.
one of the top halves.
Okay.
Yeah, cool.
No. So first, in order to graph the 500 degrees, we should subtract by 360. And that is, thank you, 140. So then we know this is 0, this is degrees, this is 90, this is 180, and this is 270. So 140 is going to be like here. And then, because it was 500, we're going to go all the way around 1 time and go around 2 times. Okay, and then in order to find this degree, wait, I want a different color. In order to find this degree, we do 180 minus 140, which is 40. So this is 40 degrees.
And then just write which quadrant we're in.
Oh, and this is, can I just do like quadrant 2?
Yep, that's it. Sweet, that's it. That's all we gotta do. Snap it up, who's next? Jonah. Do we need more do we need more time to write this down? Give you a couple more seconds, write this down. Okay. Do you want me to draw this for you? Does that help you? Or you can erase, whatever, your choice. Here you go.
Wait, I have a question. So if it's a negative, just change it to a plus? Or it should be a plus.
I changed the problem. I said, ignore this.
Matt is bad.
I said, ignore this.
Not false. Yes.
Oh.
I said, ignore it. Because I changed my mind about giving you guys negatives. That's why I changed the problem, because I don't want you guys do negatives. Does that make sense?
It makes sense.
You can say no, it's fine.
No, it makes sense.
Okay.
So-
So we just need to practice positives first.
Wouldn't you just... They threw onto me, I had to catch it.
Focus. Big math energy, let's go.
Wouldn't you just go around... Wouldn't you go around to like here? Yeah, no.
Well, we have
Maybe.
2/3 pi. 2/3 pi, this is 0, this is pi. So I'm 2/3 the way to pi.
So, yeah.
Draw your initial ray, draw your terminal ray.
Oh, okay.
What's the problem, man? You want to or not?
He needs some alcohol energy.
I do.
Do you guys think I'm like crazy? I don't know, I'm just... I had coffee a lot today.
I can tell.
Cool.
And then, so because
I finished senior grades at 2 a.m., so...
You wildin'.
because it's the second you do...
Pick a different color, and then you're going to...
Oh. I'll do this color. Am I a different color? Oh, yeah, I am. Okay.
Finding reference. Which one's our reference angle?
So you do that one. So you do...
Between the x-axis and terminal.
You do...
I wasn't even.
Yeah, it was.
Okay.
You have to do 180 minus...
Well, draw your reference angle first. Literally draw the line between the terminal and the x-axis. Draw the line here.
Oh, you mean this?
Mr. Brian?
Yes, but like, I want you to literally show what the two rays are that form this angle.
Oh.
Literally, it's the x-axis and
Miss
the
O'Brien.
x-axis.
Could have just told me in the first place. Boom. What?
You need to improve your math skills.
Are you?
Or math skills of data.
No, stop. This is culture of kindness.
I caught it.
AP kindness.
Culture of kindness.
I'm
No,
not
Michelle
an AP
Moran. Yes.
I got
Okay.
demoted down to honors.
That's on the screen.
It's a different color. Okay, cool. So how do I find my reference angle? How do I find what this is?
Don't you do 180 minus...
The angle? Or
Yeah.
pi minus this angle?
Okay, so you could do... You could just do 180 minus...
Is this in degrees?
It's not in degrees. So you do...
Pi.
When you do 2/3 pi or just pi?
Pi minus 2.
Why won't this erase? I'm trying to erase it.
It's fine. Just leave it. It's
Okay.
fine. It's
Pi...
Oh my god.
Pi minus
2/3 pi.
pi. Alright.
Is your angle. Do we understand why we're subtracting here? I don't think so. I don't think we understand why.
And then,
give me 1 second.
wait.
Give me 1 second to write this.
Get a conversion.
So think about this. Ready? If this is 2/3 pi, and plus whatever this angle is, if you add those two together, they will equal pi. Okay? Maybe we see that. So 2/3 pi plus whatever my angle is gonna equal pi, because that'd make it go all the way around. To solve for the angle, I will subtract 2/3 pi on both sides, and that's how we got to here. I'm just like showing you every step. Okay.
Then when,
Okay. Yeah. Nope.
wouldn't you have to multiply?
Okay. So imagine 2/3 pi plus whatever this angle is together are going to equal pi.
Oh.
It's
So you're
literally like
reversing it.
it's like a puzzle, right? So these two added together is going to be the whole thing, meaning 2/3 pi plus my angle is pi. How do I get angle by itself? Subtract 2/3 pi, and that's how we got here.
Wouldn't you have to multiply 3 to the left side to get the denominator the same?
Least common denominator.
To get the least
so you're
common
multiplying by 3 over
denominator.
3.
That's what I just said.
Pi minus
3 over 3. So
Yep.
it'd be 3 pi over 3. I'm not beta.
You can screw it over if you want. Just use your finger.
Oh,
and move this-
wait, am I out of the screencast?
Yes, this is the line
Damn
for the
it.
screencast. No, it's fine. Here.
Oh, I'm in. Beautiful.
Okay.
Alright. Over, wait, what did I write before? Oh, 3.
It's right here.
So it'd just be pi over 3.
It's so good. Okay, cool. So box that. Which quadrant are we in?
2.
Alright, so just do Roman numeral 2.
Wait, are we in 2?
Roman numeral 2.
We're in 2.
This is 2. Yeah, Roman numeral 2.
Yeah.
No, really take your time here.
I'm sorry,
Put
okay.
in your maximum effort.
Oh my god, we still have one more problem to go. Let's snap it up.
I'm sorry.
Keep going.
Did I get it?
Yeah, did you do 2? Quadrant 2. Okay, cool. Let's keep going. You Guys, it took 10 minutes to do 2 problems. Ugh.
Well, it took me about half a minute, and it took him about 9.5.
Shh, it's fine. All right. All right. Here we go. All right. Let's see if we can speed up.
14, 12. Can I do D instead?
Let me go through this. It'll take. Oh yeah. You do this one instead.
It'd be 210 minus.
So I made this into a positive angle because I'm not trying to give you guys negatives. On your actual law, whatever I give you, it's just gonna be positive angles. On your homework, if you see find reference angle of a negative angle, put that puppy as a positive.
Puppy.
Okay. Next. Let's keep going.
It'd be
Let's go.
you do 210 minus 180, right?
Well, first draw your angle.
My bad.
Pick a different color if that was you. That way you can add initial ray, terminal ray, and the angle.
So 210 would be like about here, right?
That's not. Is this the initial ray? You just drew the reference. Initial is always here. Initial.
There? No. That way.
Wow.
Here. And here.
Oh, thank you.
Oh, okay. Rewind your brain 10 seconds. Okay, so Zach drew the arrow on the standard position, the positive x-axis. Then he's like, oh, 210 is between 180 and 270, so he drew it here. And then it's a positive angle, so we're going counterclockwise. Now we need to find the reference angle. So we need to draw where the reference angle is. So where's the reference angle?
Right here.
Yeah, that's what we're trying to draw. Draw the little. Okay, how would you find this?
Because you do, because 210 degrees.
So 180 plus this angle is
It's
210.
yeah.
So 180 plus angle equals 210. 180 plus angle equals 210. So it's literally a puzzle piece. It's like you have puzzle pieces. Together, they equal 210. So to solve for angle, subtract on both sides. What's our angle here?
30.
30 degrees. Awesome. Which quadrant are we in?
Third.
Okay, and I'm going to do example C. Still have 2 minutes left.
Can I do C?
Awesome. No.
I already did it.
Really?
Yeah. Wait,
Oh my-
scooch back out for 2 seconds.
Okay, come on, Matt.
Let's go. Lost time.
Do I need to write for you?
Yo!
That wasn't bad.
You're good. No, you're good. Oh, wait, you get a point? Yeah. I think I gave you one. Yeah, for the second one. Good. Okay, I'll give you another one.
Nah, dog.
So you're gonna have to write fast. We're gonna go real fast.
Okay. Are we ready?
Yeah.
Hey, yo.
Next number, so it's
Yo.
1 and gonna be 2 over 12 pi, which simplifies to
Say,
1 and 1/6 pi.
7 pi over 6,
Yeah.
which is 1 and 1/6
6
pi. Okay. Do you
Okay.
guys understand how we got that?
Make graph.
Brian.
Oh.
It's gonna be
Okay.
and then you're gonna translate it. You're gonna convert it, and it's gonna be 30 degrees.
So we have pi plus the angle is going to be 1 and 1/6 pi. It is puzzle pieces together. What this means is puzzle pieces together. Pi plus whatever this angle is going to be the whole angle since we're in the third quadrant. Subtract pi. So my angle is going to be 7 pi over 6 minus 6 pi over 6. Wait, what the hell did I just do? Oh my god.
It's just pi over 6.
1 pi over 6,
You're gonna get demonetized.
and that equals 30.
And it's the third quadrant. Okay, just to throw it back a sec. So 7 pi over 6 minus pi. I have to have a common denominator. So that's how I add 7 pi over 6 minus 6 pi over 6. All right, so I'm gonna pause. I'm gonna end the screen cap.